Here we are with the full overview of Unit 5. Wanted to start with the timeline of the year. So you can see the patterns that we're seeing in this unit around waves and technology. And then over here, you can see that whole year snapshot. Each unit's adding more and more performance expectations and several assessment opportunities. We'll take a deeper peek as we go. But one other one I just want to lead with is the phenomena. How do we start this unit? Literally day one, right away, have a student in the hallway, they call someone still in your classroom. They answer it, super awkward, even put it on speakerphone. And then that kid in the hallway says, "How are you hearing me?" And that is our essential question for this unit. How are you hearing me? So again, this is Unit 5. It's about 7 weeks long, and it's themed on the waves and technology, largely doing most of the good stuff of a cell phone. Those performance expectations are essentially the wave equation, looking at digital transmission and storage of information, evaluating published materials on the effects of electromagnetic radiation, and then communicating about technical information about technological devices using wave behavior and wave interaction. So these assessment opportunities, if you look closely, they are using the big ideas of science to explain phenomena and solve problems. So let's take them task by task. So again, it ends with them actually doing most of the good stuff of a cell phone to answer the question, how are you hearing me? All right, so kicks off with that anchoring experience that generates the pattern with waves, the wave equation. So let's take a little bit of a deeper dive here. Maybe I will go back and complete this before we dive deeper. So then that spills into ultrasound, which is looking at how information is encoded and decoded in waves. Then again, right out of the performance expectations, do cell phone cause cancer? Then within the evidence statements, resonance and several other pieces are worked on in this day titled The Ear, but it's really stations that bring up a lot of great stuff with wave behavior and wave phenomena. And then, as we so often do, we elevate the computational thinking. Each unit, gets increasingly more creative and rigorous, and this is a big one right here. And then they use that to help them encode and decode information in sending a text message, which does most of the good stuff of a cell phone call, as well as a text, obviously, or sending a picture or video. All right, so going back to that deeper dive, just as we've done, we took a break with system analysis in Unit 4, but now we are building. We're back to building a more thoughtful, but this system analysis is exposure. It's going to take 6 to 7 weeks to really get the system analysis fully flushed out. So on this early exposure one, it really is talk to, might be phone does its thing. They can, after the reading, do a little more, and we'll add to that, but I just want to keep us going. So again, we're elevating driving questions. They're getting good at this. So they're asking lots of thoughtful questions. We want to save this and keep returning to it throughout the unit because they will answer almost all the questions that they come up with, although it depends on the questions. All right. Again, on day one, it is send a signal activity. They're doing this with Slinkies. It's awesome. Send the number 4 or any number. But of course, they just send 4 pulses. Couldn't be easier, but nothing builds success like success. So on day one, they've already encoded information, sent it using wave behavior, and decoded it. They do up their game a little bit more than what I just said. But again, it's going to be 7 weeks until they do most of the good stuff in a real cell phone conversation. All right, here's that reading I was talking about. This is a reading, it is exposure. They will reread this again, and we want them to learn that lesson. Sometimes you have to put a reading down and go learn something and reread it. Sometimes we get feedback that teachers drill this and kill this. They break it all down. They spend 2 days on it. That is not the intention. Exposure. So they read this and they might revise their system analysis a little bit, but they're going to come back weeks later and get most of the good stuff. They are going to use the big ideas of science to explain how cell phones work and solve the problem of a real protocol and sending a message. Okay, so there is that kickoff of the waves experiment. So to get the wave equation. So there's a big wild guess. It's fun. You might set up a big slinky, like a full length slinky that's in the supply list, or there's also a candy wave machine that you can make. Anyways, really fun. But to show how this experiment increases the rigor, I want to point out that this one actually has two, well, maybe I'll show there's two graphs. There's two data tables, there's two questions, two data tables, two graphs. And then of course, when they bring them, they weave them all together into a single wave equation. So really showing that the labs, which probably everyone's familiar with by this point in the year, is increasing its rigor and expectations. That generates the wave equation, as we said a couple times now, but we got our poster. If you're able to print that out and fill it up on the wall. And so by now, this point in the year, the room is just filled with science, the patterns that we've been creating all year. All right, so here is calling out the fact that you can now go back to the system analysis and revise it. So I just want to show that that's a, sometimes in the past, we've had the system analysis that's driven us for the learning, and that's still happening here, but it's not as complete. It's, you know, the gaps are bigger and need more explanation. As we go, we fill those in. All right, so here's another one, a new topic on the encoding of information into waves, and then ultimately you can decode it to get it back out. You know, we just have this analog music or voice signal. Maybe this is the radio station. An AM station might encode it this way, an FM this way. Look at this with more time, every student gets it. It is hard to articulate. Every student gets it, and of course we want them to swirl and be able to articulate that. But that you know, that's a 15-20 minute lesson plan right there. All right, so it front loads doing most of the good stuff of a medical imager. So this is right on the performance expectation. It is neat when they take information, they get some background information on a patient, and then raw data from the machine, and then they code in Google Sheets and then conditionally format. And when they conditionally format and the image pops out, it is a great moment. It's pretty cool. So they get it. I might even show the answer key here. So you can see here's like the kneecap, and then you see the kneecap up here. So it's a low resolution image. There's no doubt about that, but that is pretty cool. And it is live. As you change the sonogram input, that image will change real time. But going back, and then they explain that one knee had a patella injury, and you can tell by the lack of the patella tendon being complete. And then, of course, they use some other things. And of course, they're using the big ideas of science to explain how things work. All right, so jumping forward, the next task is, do cell phones cause cancer? That's aimed at that performance expectation around evaluating published materials on the effects of electromagnetic radiation. That's a good 1 day. And again, remember back to unit 3 and 4, we're building up to this. This is hard for students. And so we knew that they needed some exposure and practice before we hopefully get them to mastery here. Then we have the ear and resonance, which is a stations day, which has just loaded. It's a great 1 to 2 days. So really high interest, teacher guide on the side. Those are great days. And of course, there's a whole folder of resources along with the worksheet. That brings us to the telecommunication challenge, that final thing, putting this all together. You know, use the big ideas of science to solve problems. This is also where we go back to the reading, and I'll just flash up the reading this time. So now we really do want them really getting the nitty-gritty, the details, and putting it all together so they can use the big ideas of science to explain how cell phones work. And then the rest of the project is use the big ideas of science to solve the problem. They actually have to send a message like 150 feet or just a super long hallway, and then around a blind corner. And they do most of the good stuff of a real cell phone. So they use light one time, they use sound, amplitude modulation, frequency modulation, and several other things. But you can tell that the long hallway lends itself to light, the blind corner lends itself to sound. And yeah, that's just obviously the same one. Then when they get to the coding, here's another thing that we have introduced. With the coding getting more sophisticated, we went and talked to computer scientists and programmers and said, how do you do this stuff? They talked about using a storyboard. So this is not the first time students have done it. They actually did it with that ultrasound, but this is the first time I'm showing it in the video. And so they talk about what are the things they have to do in that engineering project. And then green is inputs, red is outputs. And then this is where you introduce the functions used. So we ideally want to get students off of just watching a tutorial and copying it. This is that. Now, there are still, I just want to be super clear, there are still multiple levels of starting structure and customized video tutorials for each of them. However, some students might not need any of that. Just this storyboard is enough. So then if we take a peek at the actual encoder, they get a 3-letter word that might be like cat. First thing that do is it auto splits it apart. This is green because you do have to manually do this because you have to select, are you doing byte 1, 2, or 3? And then everything changes accordingly. Then piecing it all together, they now can complete the portfolio. They got that problem statement, which we do every time. The overview, basic physics was the answer they were giving early in the unit. But after all that 7 weeks, they can now say the advanced physics of a cell phone, where they're really explaining how cell phones work. Then they have their final design for telecommunications. There's a lot of slide support for this. It's pretty cool. They make up a transmission protocol, think 5G, 6G. And then of course they have their encoder. You might even do each group just has a letter, and then you make however many groups, you make a word that has that many letters. So the whole class ends up needing to transmit it to make it all work. So that's that final, how are you hearing me, putting it all together. And then I did want to show an excellent, possibly whole class extension is build a guitar. So these are $3 guitars, but super fun. They really work. And in unit 6, we will turn these electric. So that's an excellent one. It has a portfolio that is highly structured. So students really can do it more independently, which might allow you to keep working with students that need more teacher attention to finish the last pieces of the engineering portfolio. With that, that is our full overview of Unit 5.